This lesson is over long division with two-digit divisors. This is an example of that sort of problem. This is the dividend, this is the divisor, and there's 2 digits in the divisor. Now for these sort of problems, there's a quick trick that you can use to make it go a little bit faster, because there's a 0 on the end of the divisor and a 0 on the end of the dividend. Whenever there's 1 0 on the outside and 1 0 on the inside, we can simply remove those zeros and make the problem a little bit simpler. So now instead of 500 divided by 50, we have 50 divided by 5. So students can usually say, what times 5 would give me 50? 10. So my answer is 10. Let's do another one like that, make it a little bit simpler. This time, let's say that there's 270 divided by 90. Now once again, it's a two-digit divisor, and the last digit is a 0, and on the inside of the dividend, the last digit is also a 0. So if there's 0 on the end on the inside and a 0 on the end on the outside, we can just remove one of each, and now it's 27 divided by 9 instead of 270 divided by 90. So what times 9 will give me 27? 3, and 3 is my answer. Okay, now let's go to a little bit harder long division problems. For example, if I have 244 divided by 12. This one's going to be a little bit more difficult. Now in my classroom we use the boxed long division method, where we draw boxes around our dividend to separate our numbers. You don't have to do it this way, but it's one way I show my students in class. Now if there's 2 digits on the outside and 1 digit in the first box, they should know that nothing times 12 will get me under 2. So they should know to automatically put a 0 above the first box, because nothing times 12 will get me less than 2. 0 times 12 is 0. You subtract and get 2, bring it to the next box, 24. Now students need to think automatically, do they know, is there something times 12 that will give me 24? Yes, there is. But if your student or your child does not know what times 12 will give me 24, here's a way that they can start guessing to try to get that number. They can underline their first digit of the divisor and underline their first digit in the second box and say what times 1 would get me to 2 without going over. And then they'll say 2, and that will give them their number to try with their 2-digit divisor. 12 times 2, 2 times 2 is 4, 2 times 1 is 2, so 24, so they can put their 2 at the top. 12 times 2 is 24. They subtract and get 0, move it to the next box. So now in my last box is 4. Now just like with the first box, if there's 1 digit in the last box and 2 digits on the outside, they should automatically know that 12 is bigger than 4, so nothing times 12 will get me less than 4, so we have to use 0. 0 times 12 is 0. We subtract and get a remainder of 4. So 20 remainder of 4. Let's do another problem. This time let's do 387 divided by 13. Now once again we're just going to box up our numbers, give everybody a little space. Now I like, especially for 2-digit divisors, to use the boxes so that students can automatically put that placeholder for the 3 of the 0. A lot of times they'll get their quotient messed up because they'll want to do they'll put the number above the 3 and then they'll have an extra place value, so it really helps them keep everything separated and in the right spot. So students should look at the first box and know that 1 digit's in the first box and 2 digits is on the outside. So 13 is bigger than 3, so nothing times 13 will get me under 3, so we have to use 0. 0 times 13 is 0. We subtract and get 3 and move it to the next box to make 38. Now most students do not know 13's multiplication facts, and I don't expect them to. And I don't like them to write all their 13's facts. It just wastes a lot of time. So a good way to estimate and guess to get a number to try is to underline that first digit of the divisor, underline the first digit of their number in the second box, and then say what times 3 will get me to 3. And most 4th graders are going to know 3. So now they take their divisor and try to use 3 to get to 38. 3 times 3 is 9. 3 times 1 is 3. Now they need to look. The number they got was 39, and the number in the box is 38. So they should know that 3 is too big. We've gone too far with 3, so we can't use 3. So they need to go back to the number before 3 and use 13 times 2 and try that number. 3 times 2 is 6, 2 times 1 is 2, and I got 26. 26 is less than 38, so I know 2 will work. So 2 goes on the top of the box. 2 times 13 we found out is 26. Then we subtract and get 12. Now we're moving 12 to the next box. Now this is where it gets a little trickier. In this box, because we moved 2 digits instead of the 1 digit, we underline both digits that we moved. And we say, what times 1 would get me to 12 without going over? And students will say 12, but we can never put 2 digits at the top of a box. We can't put 12 at the top of the box. So the biggest number that we can use is 9. The biggest 1-digit number that will go at the top of the box is 9. So they'll pull back and try at the bottom 13 times 9 to see if it will get me close to 127 without going over. 9 times 3 is 27. 9 times 1 is 9, plus 2 is 11, and that gives me 117. So now we put 9 at the top of the box. 9 times 13 is 117, and we subtract to get 10. Now it is absolutely vital that students check their remainder and make sure their remainder is smaller than their divisor. They have to double check and make sure, because if their remainder is bigger than their divisor, they've done something wrong. So they have to make sure their remainder should always be smaller than the divisor. So in this case, we have 29 remainder of 10. I'm going to do one more problem. This time we'll do 517 divided by 23. Okay, first thing we do, box up the numbers. Most students will go ahead and know that they're supposed to put a 0 above the first box, because nothing times 23 will get me less than 5, so 0. 0 times 23 is 0, and we subtract and get 5. We move the 5 to the next box and underline whatever numbers that we moved. So we're going to underline the 5 and underline the first digit of our divisor and ask ourselves, what times 2 would get me to 5 without going over? 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. So they should know 2 times 2 will get me as close to 5 as I can get without going over. So that gives us the number that we try with our divisor. So at the bottom they need to bring it down and try out 23 times 2 to see if it'll get me close to 51. 3 times 2 is 6, 2 times 2 is 4, that gives me 46. That seems pretty close to 51, so let's use it and then double check when we subtract. So we're going to put our 2 at the top. 2 times 23 is 46, and we subtract and get 5. Now 5 is less than 23, so we know we did the right thing. If this number is bigger than this number, we know that we've done something wrong and we need to go back and recheck, but this time we did something right. So we're going to move that 5 to the next box again and underline it. Then ask ourselves again, what times 2 would get me to 5 without going over? That gives us 2 to check. Then we do 23 times 2 at the bottom, that gives us 46. Put our 2 at the top, 46 at the bottom, and we subtract and get 11. Now we always double check, is our remainder smaller than our divisor? The answer is yes, so we've done the problem correctly. So we get 22 remainder of 11. Let me do one more problem just to make sure I drive home the point. This time we'll do 703 divided by 42. So we box up our numbers. We know that 42 is bigger than the number in the first box, so I'm going to put a 0 at the top. 0 times 42 is 0. Subtract and get 7. Now we're going to move that 7 to the next box and underline it. Now we ask, what times 4 would get me to 7 without going over? And we can say 4 times 1 is 4, 4 times 2 is 8, so 2 is too big, so we're going to try 1, 42 times 1. Most students should know what 42 times 1 is. They put their 1 at the top, 42 at the bottom, and subtract. They can borrow if they need to to give us 28. Now, here's where it gets a little harder. We're moving 2 digits into the next box, so we underline however many digits we move, we underline them. Now we're asking what times 4 would get me to 28 without going over, and the answer is 7. So 4 times 7 gives me 28, but we have to check it first. So we're going to do 42 times 7 at the bottom and make sure that that works. 2 times 7 is 14. 4 times 7 is 28, plus 1 is 29. Now they need to look. We got 294 at the bottom and 283 at the top. So that tells me I've gone too far. 7 is not going to work. It's too big. So we need to use a smaller number. 1 less than 7 is 6. So we're going to try 6 instead. 42 times 6. 6 times 2 is 12. 6 times 4 is 24, plus 1 is 25. Now we have 252. Well, 252 is less than 283, so 6 works. 6 times 42 is 252. And we subtract and get a remainder of 31. Now we check. Is my remainder smaller than my divisor? It is, so we know we've done something right, and we get a remainder of 31. I hope this helps. It's a step-by-step process, and there won't be an exact way to do it each time. They'll have to kind of estimate and guess through things. That's what this is for. Thank you so much.